So as I showed you my way of thinking on that is that on how I got to 6, and many of you came to 6, and then you said, and real quick though, you said on this you did x squared minus x on that. So let's write that down and see how that works.
The guy behind you riding his bike's really happy.
No, he's not happy.
He's getting beat. That's like in the zone.
Okay, so you're saying, let's pull it up here. Let's take a picture of it real quick. Still loading, I guess. All right, there we go. Let's take a picture of it real quick, and then we'll put it onto here.
So if you are TVs.
Alright, so on this, if you say x squared minus x equals, we'll use g for genius. So x squared in this case. Okay, so that's x squared is 8 squared minus 8 equals genius. And then you've got 64 minus 8 equals 56. And it works on each one if we do 3 squared minus x equals g. 9, oops, should put 9 in there. Excuse me, 3 in there. So 9 minus 3 equals 6. Pretty cool. It's a good way to do it. But if you see, you can see the pattern doing it, but that is actually it. It's 1 less than multiplication factor. Okay, so go ahead and explain 9. This is the.
You take 8 times 7, you get 56. 7 times 6 equals 42. 6 times 5 is equal to 30. 5 times 4 is equal to 20. And 3 times 3 is equal to 9. Because it goes down, for each one, it goes down. I can show it on my calculator. Because it goes, for each number you multiply, it goes down by.
But why would you, but if you say 5 times 4 is 20, then don't you have to do the next one as?
I'm taking the one that's multiplying and going down by 1.
But if you said 5 times 4 equals 20, then how can you do this? How do you get to 9?
You get, because the number you multiply goes down by 1, that's how I thought and I could be wrong.
But I still don't know how you get to 9 when you go to 3 times.
It's if I was to explain it, it's because the number I was multiplying by is to go 7, 6, 5, 4, 3. But the numbers I was multiplying, each time I took them, I was multiplying by a number. The number that was on the left-hand side of the column, I took the digit went down by 1 each time. So then when I did 3, I had 8 times 7, 7 times 6, 6 times 5, 5 times 4, and then 3 times 3.
Well, why wouldn't you do 4 times 3? I got you. I see what you're saying. Yeah. And actually, that's what the other group said. Or the one other guy said that one. That's how he had thought about it. But I think as soon as you go 5 times 4, and then yeah. Yes.
Wait, so were you like when you were talking to like the guys about this? Were you discussing this like on the ice?
I know.
I thought you were kind of fun, yeah.
Hold on, guys. Time out. We got something to talk about here. Hold on. Hey, don't worry about those guys. That's why we're watching.
I'm just talking. Just like talking to the other goalie.
That's why we lost by a goal. I showed my goalie this. I'm like, hey, look, what's this center? Anyway, real quick. Kind of the point of this was is that, yeah, I said 15 at the beginning, okay? So it is Monday, it's Motivational Monday. The point of it is that I said that. These guys are arguing with me, and actually kind of, they're trying to, like, mess with me a little bit. You teacher, you're a bad teacher. Yeah. Whatever. So for a second, I was like, I stopped for a second. I was like, wait a second. My logic was, and I don't get, I understand now.
Yeah, I can
but
see
my
both.
logic wasn't saying, wait, and I thought about something wrong to begin with, okay? And often this can happen to us, whether it's in math or whether it's in life, and you have all these other side sources coming at you and saying something, but my brain was thinking about it the right way. And I even went back to 15. I was like, wait, because it's like I disagreed with mine. I went back and like, no, wait, 15, what could? And then I understood, no, 15 absolutely cannot work in this case. But it took me a second to think through this, and it was okay. And I didn't think about it the way Ben did. I mean, Ben, I would have been done with it if I was like, okay, think about algebra 8, we're done. I mean, I could have, but I was just, that's how I went there. My tongue did, don't worry. But the point in the whole case is that whether it's me or you or someone else that says, no, that's wrong, whether I mark it wrong on your paper and say, you might actually be right. And I like it sometimes you guys question me and you say, hey, that was actually right on my test. And sometimes you're right, it was. And sometimes I can show you the hand, no, this is the way you do it. But don't let anyone say that you're wrong. You might be wrong, but that's okay. It's okay to be wrong. It's okay to be, don't let that affect you. Okay? Don't let those external sources affect who you know you are. Be who you are, know who you are, and work from that. It's okay to make mistakes along the way. I think Einstein himself, he said, what made me who I was is that I can't remember exactly how he put it, but he said, learning through mistakes. And that's ultimately what it gets to. You might not come to this x squared minus x equals g like that. That's okay. It's the process of learning how you learn, of how you learn. And not just learn, it's all things in life. People are going to say things to you that it bothers you. And you got to put up, it's hard. You got to put up like this force field. And sometimes that force field, it gets nicked all the time. I love that idea. It's that you put this thing around yourself and people throw bombs at you and you're like, ah, and you got to let it bounce off. You got to let it bounce off because sometimes it comes in and it hurts. It hurts. It hurts a lot. Excuse me. It hurts a lot. Now, I'll get to you guys in just a second, okay? And it's hard. It's really, really hard. But that's what we have to do. We have to build that force field. We got to keep it strong and know that's what makes us who we are. Don't let those outside external sources get to us too much. Okay? You want me to keep this on? Recording?
I saw something really quick. When you look at 8, I see something that
8, oh, got math side. Yeah.
I saw that you subtract 14 from 56, you get 42. If you subtract 12 from 14, you get 38. If you subtract 10, and from 30 you get 20. You subtract it, and 8 from 20 you get 12. If you subtract it, and 6 from 12 you get 6.
Yeah. Yeah, and that's where you're subtracting one off of there. It's very similar to the way that you was thinking about it. Okay, Daniel?
How do you put up the force field when people say things every day?
The thing about
Let's go to Mega High. Let's go on Mega High for the
you guys, I want to be able to give you a chance to do some of this homework in class. Okay, so we want to go through the graphing process, and we actually want to go through solving by graphing. Solving quadratic equations by graphing. We know how to solve by factoring. That's what we did all chapter 9. We learned how to factor. And then we learned how to solve by factoring. Okay? Now what we're doing is we're solving through graphing. So let me give you a problem that I'd like to start with, and I want to go through the steps that we did the last time. Sorry, it's in the wrong section there. and it is y equals x squared minus 4x plus 3. And we really had 5 steps that we were talking about. Does anyone remember the first step that we did when we were solving quadratic equations? So solving quadratic equations. What's the first step?
Find the axis of symmetry.
Awesome. Find the axis of symmetry. So, and I'm going to abbreviate that by saying find the AOS. Okay? Find the AOS. All right? And at this point, finding the axis of symmetry. How do we do that? What's the equation? It's actually a line, right? It's a vertical line. It goes up and down, splits our parabola. Right. One more time, I couldn't quite hear.
X equals b over 2a.
Almost, Lupe. Negative.
Really interesting.
Yeah, so x equals negative b over 2a. And if you wanted to just take the opposite of b, it's going to work out if that's better for you. Sometimes it's hard to just think what is hard to think of as negative b over 2a, because sometimes I forget that negative and that kind of messes things up a little bit. But either way, so I mean, you could say this is the negative of negative 4 is 4. So you could do 4 over 2a, or you could just do at the very end, do a negative. That's the way I've been teaching it. So it's negative 4, because b, remember this is a, b, and c. Negative 4 over 2 times a. What's a in this case, Noah?
1.
Good, 1. So it's 2 times 1, so it's 2. So negative 4 over 2 is negative 2. So x equals negative 2. So x equals 2. Awesome. So that's a vertical line that is on the x, whatever the y value is, the x is 2. Okay? The x is 2. Vertical line goes right on the x, or not the x-axis, but the, no matter what, y is x equals 2. All right, so what's our second step? We have our axis of symmetry. That's what cuts our parabola right in half. What's next? Yes, sir.
Identify there's a maximum or a minimum.
Not yet. You could do that now if you wanted to, but let's. The only reason why we need to do that is just to get an idea which way what our graph should look like. Sarah.
Why am I plugging x back in?
Okay, find y. But what are we doing when we do that? What are we doing, Olivia?
Find the vertex.
Yeah, we're finding the vertex. We're finding the vertex, and we do that by plugging, just like you said. So find the vertex, and we're doing it by plugging x into the equation to get our y value. Okay, so I do that. So I'm going to say y equals x squared, so in this case x is 2, minus 4 times 2, was that minus or plus 3? Plus 3. So we've got y equals 4 minus 8 plus 2. 3. Why did I do? Brain fart. So I got what? A positive 4, a positive 3. That's a positive 7, and a negative 8. So I got y equals negative 1. Are we in agreement with that?
Yeah.
That's it. Yeah, we got it.
All right. So our vertex here. So our vertex is 2, -1. So we know that that's going to be a point. It's either going to be a maximum or a minimum. And this is where we would want to say, before we start our table of values, we want to say, is it a maximum or is it a minimum? And anyone have an answer for me?
It is a.
Yes, sir.
No, then.
It is a minimum. In this case, if it's a positive A, it's going to be a minimum. If you can't remember that, you can actually go to your table of values. As long as you're doing your math right, you should see like that's the lowest it'll reach on the graph is -1. It shouldn't go any farther down in the y-axis than -1. Okay. So this is a minimum. Now, so I'll just say identify. And the only reason why you need to do this is it's math sense to say, hey, is my table of values following what I set up here? And it only takes a second. Max or min. In this case, I'm circling min because it's a minimum. So our vertex then is, what was that, 2, -1? Yes, 2, -1. So we're going to take our x and our y, and we're going to take that, and we're going to take our vertex and just put it in the middle here. So we got 2, -1. And remember, I said that I want 5 points. Okay, this is your first point. And then I choose one that's larger than it, just an x value that's larger. And I like to choose this one away. I mean, it doesn't have to be, but. And then one that's smaller than it. We know since the parabola is symmetrical, these two values should have the same y value. Okay, and we know that this is right in the middle of the parabola. And then we'll choose one more, 4 and 0. Just making sure that this x value, these go the same amount away, and then we don't have to, the same amount of distance away. I mean, I could skip 2. I could go to 4 here, and then 6. But this one also would have to go 2 away from the vertex. This would have to be 0 and then -2. Just make sure your intervals are increasing by the same amount. That was kind of the challenge behind this problem back here, is that one of our intervals didn't go by the same amount. And that's what we had to figure out, how are we going to deal with that interval. So, anyway, moving back. So we just simply plug and chug. I guess I'd rather deal with a 1 and a 0 because I know in multiplication sense that's going to be easier. So if I do 1 squared minus 4 times 1 plus 3, I see that's 1. -4 plus 3. Okay, to me, that right there, that's 4 minus, that's 0. Okay? And then so I know that is also 0. And we could simply put it in there if we wanted to. But then the x squared, 0 squared minus 4 times 0 plus 3. We've got 0 minus 0 plus 3. Obviously, that's 3. And we would expect, what would we expect 5 to be? Can you give me a math statement without doing the math? What would tell me something true about if x equals 5? Jenna.
That would be 6.
Well, okay. I didn't do the math, but if I did the math, maybe it would be. Tell me something that's true without me even having to think through the math. Austin?
5 is why not valuable. I'm greater than 3.
That's what I was thinking. I just know real quick that the value for 5 and the value for -1, if x was 5 or -1, would be greater than 3. Okay, and I could say if it was 6, it would be greater than 3 and greater than the value for 5 and -1. But anyway, now the last thing that we have to do. What's the last thing we have to do? Yes, we're graphing. We're solving by graphing. So if I'm going to graph, I'm going to take this down here. Let's see, we go to my contact here. It's not that one. Here's my XY grid.
Where's it at?
Yeah, I think I have to go to the next page and put it on there. So now what I do here is I know my vertex was at 1, or was 2, -1. So I go into down 1. And then looking at my values, unfortunately I put this thing on there. 3 and 0 and 1 and 0. So 3 is 0. 1, 2, 3 is 0. And 1 is 0. And you got 0 was, what was it, 3?
Yeah.
0 is 1, 2, 3. 3, and then 1, 2, 3. So this is what our parabola looks like, and of course it goes on. I always have trouble making the actual view, but it doesn't have to be perfect. But what we can do here is we can solve this equation by graphing. Okay? We can solve this equation. Solving it, it's right here. This equation equals x equals either 1 or x equals 1, 2, 3 or 3. So our solution set is 1 or 3. Remember when we factored this. Remember in chapter 9 when we factored x squared minus 4x plus 3. Tell me two numbers. Tell me two numbers, or when we factor it and solve. Tell me two numbers that multiply to -3 and add, multiply to 3 but add to -4. Yes?
-1 and -3.
-1 and -3. -3 times -1 equals +3. And they both, -3 plus -1 equals -4. So we would say x minus 3 times x minus 1 equals 0. And we can multiply that out and check it if we had to. X times x is x squared. X times -1 is -1x. -3 times x is -3x. And -3 times -1 is +3. We combine our like terms. X squared minus 4x plus 3. Give me 1 second. And then we solve this, x minus 3. X minus 3 equals 0. X minus 1 equals 0. Okay? So we add 3 to both sides of the equation. 3 minus 3 is going to equal 0, so x would equal 3. 1 minus 1 would equal 0. So our answers, our solution set is 1 and 3. But what that meant back in chapter 9 was that it crosses, this graph crosses the x-axis at 1 and -3. Okay? Or 1 and 3, not -3. You have a couple minutes if you need it. Try not to make a ton of noise out in the hall. Yes.
When we get that done, the only one I couldn't get was number 10.
Okay, so what's B in this case?
-3.
No.
There's
That's C.
there's no B.
So it's 0.
Wait,
So
which
there's-
one are you still wearing?
What? I'll go ahead and
Oh, okay. All right. Oh, okay.
Thanks, Chicken. So that's solving quadratic equations in a nutshell. And it's that 5-step process that we went through. First, you find the axis of symmetry. Then you find the vertex. Quickly, just to make sure you know that your graph is going to look the way that you want it, you know that there's going to be a minimum point of your parabola. Okay? And that means this one is pointing upward. So you got an idea of what it's going to look like. If it's wrong, then you got to come back and say, maybe I did something wrong. And then my vertex, you know what I often do? Sometimes I forget like this negative here, the negative of the negative, like I was saying before, and that's the negative. If I would have said that that's -2, then that would have kind of messed up my equation a little. And I say, wait a second, that didn't work. Okay? So that's often where I have to say, okay, that's all I'm using, that identifying if it's a maximum or minimum. And then you plug in your table of values, then you graph, and to see where it solves, you look for your roots. Your roots is where it crosses the x-axis. Okay? And you can check it. You can go back and factor and check it and see if it's right. Now, some of them you can't, it won't check out just right, but we'll talk about that later. Sometimes they're not going to have roots. Okay? If you get a parabola that looks like this, okay? If you get a parabola that looks like this, and it's a minimum, but the minimum is right here, and it goes like this, it doesn't have any roots. That means there's no solution to this problem. Okay? Sometimes you're going to have just one solution. Okay? Sometimes with a quadratic equation, you're going to have just one solution, and that's when it touches right here. One solution. That's when the vertex is on the x-axis. That's when that vertex is touching. This one, there's no solution. Your book will write it like that. That's not 0, or maybe it writes it more like more up and down. It doesn't matter, but and then sometimes you'll have one that points down, okay, and that's your solution, and that's your solution. I don't know. Maybe right there. Some of them, they don't come out nice and neat. That's why I was trying to choose one for you that were nice and neat. But yes.
So the solution is when it touches the x-axis. Right?
You got it. And that's all we were doing in chapter 9. You just didn't know that what those graphs look like, what the trinomials look like. That's exactly it. It's just wherever the parabola touches the x-axis. When we factored those out and then solved for 0, solved for x, when we made it equal to 0, all it was doing was we were trying to identify where it touches the x-axis. You just didn't know it yet. And then I'm going to show you something later in this chapter, and you're like, why did you just show me that to begin with? Because this is a pain in the butt. But you'll be fine. You'll be like, oh, cool. But I want you, it's kind of going through the process and understanding why we're doing what we're doing. You really need to know what? Do you need to know what? Okay. Focus on that for a little bit. That's all I'm trying to get you to focus. So now what I'm going to do is I'm going to turn you to your homework. Okay, I have posted the chapter 10 assignments. It's going to look kind of weird. Actually, let me pull it up for you. So as I pull up these assignments, it says AOS and Vertex. It says page 528, 10, 12, 15, all these problems here. But then they're also right here. Okay, notice the next 2 days' assignments are all the same thing. What I want you to do is to go through the assignments, and I want you to just do what we did. Find the axis of symmetry, find the vertex, then do a table of values, and then graph it. And you've got all these problems. Some of them are odd, some of them are even. You can use my book if you need to.
So this is 17.
So anyway, just follow those, do those. There's some Khan videos on there if you'd like. But I'm here for your assistance. There's graph paper in the back, so feel free to use that if you'd like. And any questions? Feel free to work with each other too. Check your answers with someone.
Yeah, let's go. Let's go, Greece.